simplify this expression. Before we start, remember that sine squared something plus cos squared something is equal to 1. So 1 minus sine squared theta can be rewritten as cos squared theta. In the denominator we've got sine 2 theta, which can be rewritten as 2 sine theta cos theta. So the expression becomes 2 root cos squared theta over 2 sine theta cos theta. We can cancel the 2's, top and bottom, and we can take the square root, which means we end up with cos theta over sine theta cos theta. Now we can cancel cos theta from the numerator and the denominator, which means we end up with 1 over sine theta, or if you'd rather, cosec theta. And that's the answer to part A. Part B, transform the expression into the form of r sine theta plus phi. Let's just remind ourselves about the double angle identity. R sine theta plus phi can be rewritten as r sine theta cos phi plus r cos theta sine phi. The coefficient of sine theta in this expression is r cos phi, and in this expression it's root 7, and the coefficient of the cos theta term is r sine phi, and in this expression it's 3. So that means we can write root 7 is equal to r cos phi, 3 is equal to r sine phi. Dividing r sine phi by r cos phi gives us tan phi, which means that phi is equal to the arctan of 3 over root 7. 3 over root 7, which if we evaluate that, making sure your calculator is in degrees, not radians, we get 48.59 degrees. Right, let's make a bit of space. The next thing we want to do is to find what r is. So remembering that sine squared plus cos squared equals 1, we can say that r sine squared theta plus r cos squared theta is equal to 3 squared plus root 7 squared, which means that r squared is equal to 3 squared is 9, 9 plus 7, 9 plus 7 is 16, which means that r is equal to 4. So that means that the whole expression can now be rewritten as 4 times sine theta plus 48.59 degrees. That's from here. And that's the answer to part B. Part B2, identify the maximum value. So this is the expression that we've derived. The first thing we'll look at is the sine term here. Sine varies between -1 and +1. We have an amplitude term there of 4, so that means that the function will vary between +4 and -4. So obviously the maximum is 4. And then it says, what is the phase? Well, there it is. That's not hard, is it? 48.59 is the phase of the angle. And that's the answer to part B2. Part B3. At what angle, theta, does the expression attain a maximum within that range? Well, sine waves look like this. Notice I've cheated a bit. This sine wave has a maximum of 4 and a minimum of -4. Normalized sine waves have a maximum of 1 and a minimum of -1. So sine waves look like this, and this function looks like this. Now, when theta is 0, we're calculating the sine of 48.5, which is the value we've got here. So the maximum is going to be here, which if you sort of scan down, it's going to be a little less than 45. So if we take 90 minus 48.95, we'll get the value to be 41.41, which is a little less than 45 as we expected. And that's the answer to part 2B3.